Hi everyone, Dr. Bruno here. In this video, we're going to go ahead and provide some introductory concepts for statistics for health sciences. And we're going to break this lecture down into a series of 10 little snippet videos that I think will help to break the concepts down in a way that will be much more manageable. So without further ado, let's go ahead and get started. Okay, so the first video that we want to try and orient you to for Stats 345 is to introduce you to some basic statistical terms. The first thing that I think is really important for you to understand is the difference between science and research. As you can see from the slide, science is an impartial weighting of empirical evidence. Impartial means that it's free from bias, okay? Whereas research is a scientifically structured way of solving problems. So where science is an impartial way of weighing different evidences, giving certain studies more weight compared to other studies that get a little bit less weight, research is more of just the scientific process of how we approach the problem-solving issue. Another important variable that I think is important for everybody to understand is the difference between a variable and a constant. So a variable is anything that has a characteristic and that the characteristic can change or can take on a different value from person to person. So for example, a variable of interest may be a person's age. Every person in this class likely has a different birth date. And so the age of one student varies from the age of a different student. Some students may be 18 years of age, some students may be 22 years of age, and even other students might even be above 22 years of age. So a variable is merely anything that we can assign a different value or take on a different value in society. These variables can then be broken down into what are called categorical variables and continuous variables. A categorical variable is a variable that can take on different categories or names in some way, shape, or fashion. So an example of a categorical variable could be things like eye color. Some people have blue eyes, some people have brown eyes, some people have different colored eyes. Same thing with hair color. Some people have one hair color, some people have another hair color. So when we're talking about variables, we're talking about different categories that we can assign or bucket people into in that way. If we're sticking within the realm of a categorical variable, one of the things that we need to think about is a dichotomous variable versus a discrete variable. Both of these, a dichotomous variable and a discrete variable, are both in the family of categorical variables, meaning we can assign people to different categories. But in the case of a dichotomous variable, it means that the category can only be one of two possible choices, okay? Whereas a discrete variable is also categorical in nature, but it has an unlimited number of categories in which a person can be assigned, okay? So for example, if we were to think about things on a dichotomous variable, I might be interested in knowing whether or not the income of people who are younger than 45 years of age, if their income on average is different from people who are over 45 years of age. In that type of situation, you would either belong, based off your age, to the group that is younger than 45 or the group that is older than 45. So you would fall into one of those two groups, one of those two possible choices, making it a dichotomous variable by nature. Whereas if we use that same variable, and now we talked about it on a discrete perspective, we're talking about multiple categories. So let's say we had 18 years of age to 45, 45 to 65, and above 65. Even though we only introduced one more category, we are now having that become a discrete categorical variable because we have more than two possible dichotomous outcomes. So I hope that's helpful. On the continuous side of things, these numbers can take on any value, and for that reason, they fall along a number line. So they can fall from negative infinity to positive infinity, or in other variables, they may start at 0 and go into positive infinity. So as an example of something like this, you might look at your age. Either you have an age, which is above the 0 on the number line, or you have no age. You're not born. So in that particular case, because I can assign people a continuous number positively into the future along that number line, that is a continuous variable because they don't fall within these structured buckets like categorical variables do. And because of that, I can assign people an age as little as 1 day old all the way up to 120 years old. I have all those possible numbers that can fall within that. Lastly, a constant is anything that is the same for all cases. So if I was to do a research study and I was to say, what is a constant? That is the thing that is consistent regardless of who's in my research study. So in that typical situation, this is what we call a non-changing value. And so if I was to say everybody in this class is a undergraduate student at Drexel University, that is a constant that all of you have, even though individually you vary from person to person. Another important term that I think is important for you to know in this class is what are called statistics. And so statistics are a way in which we collect data, organize that data, analyze that data, and interpret that data in order to help make sense of what the typical value is and on average how one person differs from another person in the data set. So statistics is a process in how we collect information, how we organize it, how we analyze it, and how we interpret it back to a larger population of interest, which takes us on to this next topic here, which is differentiating a population from a sample. So when we talk about populations, we are talking about every possible person that comes from a set that could have those characteristics that we're looking for. So as an example, if I was interested in students' level of satisfaction at Drexel University after their freshman year, I would want to make sure that I polled every single student at Drexel University, not just health sciences students, not just nursing students, but students across the College of Nursing and Health Professions, students across the College of Engineering, students across the LeBeau College of Business. So that way, every possible student who was a freshman finishing their freshman year would be included in that type of analysis. But oftentimes we realize that not every person is going to want to be in a research study, and it may not be feasible to ask every single student about their level of university satisfaction. So what we do instead is we take a smaller group of people, which we call a sample, and these sample of individuals are used to make broader inferences, or we try to what's called extrapolate, or we try to make some assumptions based off what we see in the sample as to what likely will occur in the population if we actually did evaluate everybody in the population. The last couple of terms that I want to introduce you to is understanding the difference between an independent and a dependent variable. So an independent variable is what I will tell you is the categorical variable. And as you can see from the slide, it is used to examine their effects on another variable. What the researcher is manipulating, often but not always categorical with groups or levels. So for all intents and purposes of this class, the independent variable is your categorical variable, right? It is the tool, it is the intervention, it is the thing that we are trying to do this or that and see how it changes an outcome variable of interest. An example of an independent variable would be a medical drug. Oftentimes pharmaceutical companies, before they're able to use that drug in society, has to determine two things: safety and efficacy. In order to establish safety and efficacy, typically what these researchers have to do is what's called a randomized, double-blind, placebo-controlled trial. Really what that means is you're taking a random group of people from the population of interest, and you are randomly giving them either the new experimental drug or the placebo, which looks and may taste and be experienced exactly like the experimental drug, but it just has sugar. In order to randomly assign that, the ability to randomly assign somebody to either the intervention or to the placebo, the ability to do that and see that categorical difference is the independent variable. That's the thing we're manipulating. You're either getting the drug or you're getting the placebo, which is the absence of the drug. To determine if the drug is effective, we would then have to measure what's called a dependent variable of interest, or as we call them, the outcome or the effect variable. This is the thing that changes because of the treatment or intervention that you received or the placebo that you did not receive. So the dependent variable is going to change from person to person based off of whether you were given that experimental drug or you were not given that experimental drug. So I hope that's helpful. Independent is our categorical variables. Dependent variables are our outcome or our effect variables. The last difference in terms of key statistical terms that I want you to know in this class is what is called a parameter versus a statistic. Recall from a couple slides ago, we talked about populations of interest, about every possible unit that could meet our inclusion criteria. If in fact we are performing statistical analyses with population parameters, then that is a statistic that is used to represent the population at large. You've actually were able to measure the entire population, and you were able to generate data that is truly from the larger world that we're trying to inference about. A statistic is that same representation, but is it a numerical measure that describes characteristics of the sample? Remember, the smaller subset of people from that larger population. So if we're able to measure an entire population, we call those parameters, but oftentimes we are forced to use a sample of people from the population. And so the way that we organize, the way that we analyze and interpret those data is what's called statistics. So I hope this first video was helpful. In the next one, we're going to get into levels of measurement. See you there.